Hey everybody, my name is Brent Salisbury.
I'm Madhu Venugopal.
We're both with Red Hat. Today we're talking about vSwitch, vSwitch database protocol. We want this to be, I mean, we've got slides to kind of reference, but we'd love to have some interaction because it's just boring hearing us talk. And so please just interrupt, call a foul. We're going to ask you guys questions because, you know, we're developing this stuff with community, so some of you guys in the audience, whether you work for a company or don't work with a company, we want to work with you because, you know, we work for Red Hat and we do what's best for the community. And as somebody that just joined 2 weeks ago, I can honestly say that is the only direction. So when we say that and we sit in meetings, it's what's best for the community. So we just got out of lunch. We like cats. Figure out where you sit in here, and you know, we left it generic. Interpret it how you will.
Yeah.
So vSwitch database, it is reference RFC now. For the most part, you can think of it as a management protocol. It does have functionality that's beyond that, and it's kind of morphing into more of it. You know, we've had SNMP, and you know, we can kind of go down a list of failed. Well, you know, people look at SNMP and say it's a failed management protocol, but we've had SNMP for at least 15 years, so I'd probably call that a pretty good success, just for something to be as widely deployed as it is. But you know, it's getting a little long in the tooth. So vSwitch came out of Nicira. It's now published, and it's nothing really more than JSON RPC with a schema attached to it on the software side. There's also a hardware schema, so you know, it's nothing more than here's what this model looks like. And you can go down the list. We don't want to really read it to you because it would be boring, but CRUD operations. Probably some of the highlights with the controller though are going to be it can be set as a listener, so it's just going to have an open port on either a controller or a manager, or it can be sitting on the switch. So there's going to be a port sitting there listening on 6640. Some of you probably remember it as 6634, things like that, but it's actually a registered IANA port now. And it can either be an initiator or a listener. So the main thing, there's probably one provisioning piece to this, and we were talking to some guys from PayPal eBay yesterday on how to maybe figure out how to make this self-configurable, or some discovery mechanism to it. But you'd have a vSwitch that you would either need to say, I want you attached to this controller and now start programming the data path, or you would have the controller attached to the vSwitch and begin the initiation. It's got these little 5-second hellos that keep persistence. The second anything changes on, so if a port goes up, there's going to be a notification message that comes in. It's all JSON. It's going to, you know, notify of a port that's there, and vice versa. If you modify a port, so any change at all in that database, there's going to be a message thrown up to the manager. So it's pretty cool. You get real-time understanding and state of the configuration in the network. It also does include things like MAC addresses. So if you have MAC addresses on being learned on, let's say, a learning switch of some type, that's going to be there. Or you just program in as a reference. Yes, sir?
I'm new to OVS. So if somebody runs OVS control on the Linux box, does it go and modify the local database and then that will send the event, or does it directly? Is your question? So
Yeah.
if somebody runs a command line interface of operating system itself, does it talk to database and then that sends out the event?
Yeah, so the OVSDB, as I was explaining, right, it's a bidirectional. Oh, sorry. So his question is, yeah, OVSDB is a control management channel between the controller and the server and the client, right? Server is the host, the node that is running the OVSDB server, while the client is the controller in this case, right? If somebody touches the CLI on the compute node or the node, does it get reflected back on the OVSDB and comes to the channel, right? The answer is yes, because the OVSDB is a bidirectional JSON RPC. So there can be multiple clients which can be acting on the same DB. The client can be CLI is a client, right? And the controller is another client. So any update happening on the on the database gets reflected back through the monitoring process, right?
So when you run something on the CLI, it first goes to change the state of the DB,
Right.
and then that goes change the kernel and everything. That's how it works.
Yeah.
Not some IOPTLs or something directly to.
No. So before we go deeper into this lot of words here, right? Anyone here is really new to OVSDB or have any questions about? Oh, there you go. Right? Questions about why do we even need OVSDB or anything like that? Even more basics than that, right? Few, 2 or 3. Right? I think we have to go a bit more.
Oh yeah.
Yeah.
Cool.
Right. So before going into this one, right? When we started working on this project like a few months back, we know of OpenFlow. All of us knew about OpenFlow. We are like going deeper inside. Then we started looking at OpenStack, looking at the integration piece. We didn't find any good way to manage these switches, right? Then of course we started looking at the reference platforms, looking at the vSwitch, OpenVSwitch agent, right? Then we saw a lot of CLIs being executed on the compute nodes, right? Then we figured out, okay, why would we need a CLI? Then we started digging deeper. Then we started realizing about OVSDB, right? Till then we didn't even know about OVSDB, right? It's like a few months back, really. So once we started OVSDB, of course, we both started looking at there's no RSC at the time, it's only pure draft. So hacking on things. It's again a simple bidirectional JSON RPC. We hack things. Nothing really great about it, right? It's simple stuff for us. But once you start writing applications on top, right, then you start realizing it's not just a protocol, really, right? It's really an enabler. It enables much beyond a simple protocol can do, right? So once you start writing simple library, so we wrote a library called OVSDB library, hacked it up, made it work. It's all great. Then we wrote the layers on top, right? The REST APIs for that. It's pretty cool because once you have REST APIs, any application can talk. You don't have to be a SNMP kind of a client. So then we started writing Postman scripts, right? And then calling scripts to configure the OVSDB, right? That worked very well. Then started using the OpenStack interface, right? So let's look at OVSDB as a simple API mechanism, right? You call the API. In fact, the reason it's called JSON RPC is really a remote procedure call. There's nothing beyond that, right? How we implement the actual protocol inside, whether it is a TCP session or how do you maintain session, it's totally a library specific one. Right? From an application standpoint, think about it as a remote procedure call, and there is a database running on the OpenVSwitch. Magically, if you update the database, something happens on the data path, right? Just imagine that way, right? That is what OVSDB is all about, right? It's nothing more than a RPC call with a database on the other end. You change the database, things magically start happening on the OpenVSwitch side. The beauty behind the OVSDB, as we all know today, is that it is not a hard-coded database table, right? It is schema-driven, and the schema is exposed based on the RFC. If you look at the RFC 7047, it doesn't dictate any schema, right? OVSDB, of course, one of the primary uses on the OpenVSwitch. It is essentially 2 parts. It's not just one part, one phase. It's 2 phases actually. First phase is the RFC itself. It talks about what are the different methods you can call, like create, modify, listening to the updates, monitoring, so on and so forth. That is the actual protocol piece where now you explicitly say that these are the different mechanisms that this particular protocol must support. Okay. Additional to that is the schema, right? The schema is where the real things starts getting interesting, really interesting. OpenVSwitch has its own schema. We are hearing new protocol vendors, new hardware vendors. They use the same OVSDB RFC, but they have their own different schema, completely different schema. It's called like hardware beat-up schema, and so on and so forth. A lot of guys are coming up now. So what happens here is we write a simple library like the one that we have in the OpenDaylight. It's quickly becoming the reference implementation in kind of Java world, where we write the library and the plugins, we give it to the community right out there, and we started seeing like already 3 or 4 vendors and research community started taking it up, writing their own schema, right, and exposing themselves. So now, as we are discussing here, right, the title is aptly suggested by Brent here, where it is not just a management protocol really. It's really an enabler for various other aspects of things, right? Like OpenStack is one example, and a lot more is coming. right? Yeah, so that's the high-level picture of what OVSDB is. We didn't even realize the strengths of it. I didn't realize the strength of it till I started working on it. Then we got fanboys of OVSDB, right? And we are here talking about that. And you see a lot of close relationship with OVSDB and OFConfig, right? Because both are trying to do similar stuff. So far, OVSDB has served our purpose really well. So we're here to talk about it, but let's see. OFConfig might even catch up.
Yeah.
Right. Right. I mean the OF config. Yeah, right. So OpenFlow is, as I said, it's mostly data plane where you configure flows. OVSDB is to do everything else, right? So it's to me it's a hidden gem, right? We didn't realize it till, right? But yeah, it is. Yeah, yeah. Yusuf.
Yusuf.
Apart from OpenVSwitch, which other hardware switches use
The question is, apart from OpenVSwitch, what are the different hardware vendors? I think you have to wait for the announcements rather than me announcing it here. It may not be right, right? So it's not a secret, right? It's a public information. You just you go to Google, figure it out, it'll be there. I don't even know if I should be saying that already here, right? Yeah, rather I would not do that. Yeah, yeah, thanks.
And you know, it's an open protocol. Oh, yeah. And that's so.
Right. So the question is, we have controllers and managers there. What is the difference, right? Go on.
Yeah, and it's just wherever you decide to implement it. So we could just as easily probably break this out into a manager. That would be, you know, in conjunction with the controller. So there's interesting things that come in from, you know, on the OpenFlow side that's helpful that we wouldn't necessarily see from, you know, you're attached to a controller now, and let's say, you know, you've got to pack it in, or you're doing topology with LDP. So there's some things that are nicely complementary there. So there's a lot of correlation between some of the southbound protocols. Yes, sir.
So just one.
Oh.
So just to be clear, right? If you look at controllers for OpenFlow, manager is for OVSDB, right? So that's why the controller is connected to every bridge spawned by the OVSDB server, while the manager is for the OVSDB server itself. So there can be multiple managers. I don't know if you guys were there in yesterday's demo that we had for the simple OVSDB thing. We had the mininet, right, as one thing, and we also had the controller controlling. So we had two managers. In fact, there are three clients, essentially. We use CLI also to do stuffs. The mininet was managing the OpenVSwitch, even the controller. But end of the day, everything worked out well because we do the monitor, it's bidirectional RPC, and it's completely transaction based, right? So there's no way we can start screwing things where multiple guys trying to do it, right? Because it's transactional. If everything fails, everything succeeds, right? So yeah, manager means OVSDB, controller means OpenFlow. Yeah. Yeah. So you had a
Question, sir.
maintain compatibility if other people are coming up with a different scheme? Researchers are coming up with schemes, so how do you maintain?
So if you look at the OVSDB, we're talking about source code compatibility now, right? Or
Schema. Yeah. So one thing we're looking at over the next 6 months is to make this a little bit more generic. So right now there's hard classes that everything serializes and deserializes against in the library. So there's 15 tables. We only have the software. Those are the software tables that are implemented. So you know we've already had people come to us and start working on the hardware. Now whether that, you know, ideally that probably lands upstream maybe, but we need to see how. As long as it's kind of consistent, I think it makes sense going upstream. If it's very custom and proprietary, then probably doesn't belong upstream.
so our objective, we both are committers of OVSDB project, right? So what we are trying to do is anything that is out there considered as standard, right? Because there's no standard around this schemas, right? We all know that it's schema is out there. If you go to the openvswitch.org, you can find two schemas already. One is the OpenVSwitch schema, right? We'll come there. Other one is the hardware VTIP schema. So we consider like OpenVSwitch.org as a kind of a standard for us, right? Whatever is represented there will be part of the core Open OVSDB plugin branch. We'll maintain that and whatnot. But if a hardware vendor writes their own schema, it won't be considered as a part of the core project. It will be a plugin written by the hardware vendor, maintained by them.
And those schemas will be complementing the existing schemas. I don't think they would go change the fields of an existing schema.
No, it really depends on the implementation, right?
Some tables have depreciated, so
Yeah.
add and delete. So I haven't seen where a table actually is going to delete fields though, because that would be a problem. Because we deserialize against that. We'd have to ignore some fields and things like that. But
So even between OVS 1.109 and 2.2.0, we found few tables have been deprecated, few have been added, right? So if you look at all those compatibility, those things will be managed by this implementation, right? Because it's our responsibility, or is the maintenance responsibility to make sure we can maintain the backup compatibility between versions, but we cannot possibly start maintaining all the vendor specific ones until it goes upstream, until it's accepted as standard. It will be maintained by the vendors who write their own plugins. But
isn't there an RFC which describes the schema?
no, no. Schemas are not RFCs, right? Schemas are all implementation, right? What is RFC? As I said, the RFC is this one. See, the most important thing about it is schema is a database. At the end of the day, it's a database thing, right? That it's better to be not RFC, really, right? This has to be RFC because we are talking about reference implementation here, right? If somebody wants to write an OVSDB-based OVSDB server on their own platform, they don't want to write an OVSDB client or a controller. They can take whatever is implemented already by few folks like us, right? Or the community here. That's the idea of OpenDaylight. OpenDaylight is to make sure we give all the base plumbing stuff. You guys innovate on top of it, really, right? So that's the goal again. But for OpenVSwitch at least, since it's OVSDB, we want to maintain those standard schemas. So it's just a plug and play, like OpenStack. OpenStack did not come and implement their own plugin for OpenVSwitch. That is already there. Just make use of it.
Right.
Yeah.
So that left column, the actual methods in that implementation, that stays consistent. Schema on the right can, and we've knocked around, well, we could make this, because the first thing we do is exchange, we pull the schema from the data path. So, we could just as easily probably have nothing concrete in classes in the library. But when it comes to debugging, that would get a little nasty because it's going to set up and tear down every time. So we're trying to make it as generic as possible, but at the same time make it not insane to debug.
So post hydrogen and before helium, right? The one of the work that we have, high priority work, is to the right side, whatever you see, that will all be contained inside a bundle called a OVSDB library bundle, where anybody can take it and start using that, right? Nothing specific to implementation. While the left side is going to be OpenVSwitch plugin, which uses that library. Today we kind of put them together into a kind of mishmash. We want to separate it out cleanly and make sure the left side here is going to be a plugin for OpenVSwitch with back compatibility and whatnot. Right will be a library. So if anybody wants to write their own schema, you make use of the right side as is, and maybe copy from the left side. It's fine, right?
Mm-hmm. And to your point, we do maintain backwards compatibility. So like, we started with 1.4.1, now we're up to 2.0.9. So, both of those deserialize and serialize how they need to. And then as new ones come out, the easiest way to test it is if you just populate the field. If you populate OVS with that field or the new field, if it throws a Jackson deserialization error, you've got a problem. It's typically just the data type that you've defined.
And to answer Yusuf's question, right, I just realized one thing. There's an open source project in GitHub, right? They use the same library but different schema. You can take a look at that. Yeah.
I think it's actually labeled Midakira, so
Yeah.
it's not top secret or anything.
It's out there, so it's open source, so you can take a look at that.
Yeah.
Is that monitor and show is same?
Sorry?
Show commands normally get to the CLI and traditional.
Same mechanism. So monitor absolutely is. is pulling information, which is basically, it's not too far off from a show, SQL call.
So monitor is something when there's an update happening on the.
Right.
It's going to, we keep monitoring things, right? In fact, the monitor is something where you can represent only once, and update you're going to keep getting information.
And that's probably the most interesting thing, because when we're hard coding in by hand using the client, you're getting what that state is at that moment. But we keep a persistent channel there that every 5 seconds is refreshing. So the second there's a change, it's going to notify upstream into the controller, exactly what's just changed. And then so we inventory at initialization. We'll do an inventory, and then we just diff from there.
And interestingly, what we have done in the OVSDB library that we are writing here, we never query actually. We don't use a select at all, right? Select is one method which we can use to select whatever we want to from the network. Rather, I got lazy really, right? So we did when we connect to the OVSDB server, we say monitor all, right? So any change, you go and keep getting the updates from the server, right? Channel is busy now because every stats we keep getting it, but it is the richest possible data that you always keep in the cache. So once you execute the monitor only once during the initial connection, from there on we never go back to the OVSDB database. It's always local cache. The cache is always up to date, right? So, and we always read from the local cache. We never go there, and we destroy the cache when we disconnect and we reconnect and all those things.
What database do they use? Like SQLite or?
You mean in the vSwitch thing?
On the compute node where you have OSDB server running. So do they use SQLite or what?
I don't know.
If you look at the file, it's just, so there's the initial schema that has the populated config, and then each time there's a change, they just plus it. So it's increments each time with the change.
Or is it a flat file?
Yeah, it's totally flat. Yeah.
I haven't even looked into it. Right? I call the query and it comes to me as JSON. What do they care, right? So, but yeah, it's a good question. I didn't even know.
Yeah. So here's kind of an example of, this could be orchestration, this could be a controller. This is, OVSDB is not tied at all to OpenFlow in the sense of OpenDaylight, OpenFlow is a southbound. There's plenty of other protocols there. I think that's actually more interesting as opposed to, as my boss in the second row here says, we're not dogmatic about this, we're pragmatic about it. We don't really believe in, whatever works and whatever the community works for the community is what should be there. Any questions before we go on? Yes, sir.
Talk about OVSDB, right? So is the OVSDB persistent across reboots of the compute node?
The question is OVSDB persistent across reboot of compute nodes? It's actually defined in the schema itself. The schema itself we can say whether you want to be persistent or not persistent. It really depends on the schema, right? And you will see that in many cases it will be persistent, some cases it will not. But again, it depends on the schema that you implement. Yeah.
So by default, our implementation is, and it's OVSDB conf, and in it is the initial, and then all the diffs all the way down.
Yeah.
So it just builds on top of that as it builds out. We don't store any of that. We just, we pulled inventory at connection. If it goes away, we just repull it. So we're not storing any of that persistence. We like that.
And for a scale system, right, what we have today may not completely work, right? Because we are so greedy, we keep getting all the updates from the network. There are optimizations that we can definitely work on, right? The reason we are here, all us community, we expect some engineers to come and say, you know what, guys, the implementation is very greedy. Just let's go and try to fix it, right? Those are innovations that we can keep adding things, right? Scale is one of the primary things that we have to start concentrating on. With the current implementation, we monitor only once, right? That means we're getting updates every single second. Any stats update, we keep getting it. We don't need to be that greedy because most of the time, we're not interested in that update, right? But it's simple to implement, things work, but those are the things that we have to optimize, keep improving on top.
Yeah, and yes, sir.
Basically, you could run OVSDB on a physical switch, reporting the link state, and then waiting the OpenFlow message of port state.
So any kind of control is going to be, it's not doing control at this point. So it's going to tell you a link has gone down or a port's gone down or there's any kind of change in the data path, but it's not going to go reroute traffic. There is some, I think Martin had a post on his blog recently on elephant flows using IPFix. I think that's an interesting use case because you've now got, you've got programmable data paths out there that if you need to, have a path that, is less reactive, arguably, then you can, basically signal that path throughout the network. But we haven't touched any of that yet. So there's a lot of interesting things you can do with it. There's a lot of interesting, knowing the MAC addresses, knowing where they live, correlating that kind of data with OpenStack. That it's as creative as you want to get. We're kind of still working on nailing down the basics and integration with OpenStack.
So one thing you have to understand about this OVSDB and OpenFlow, right? They both go hand in hand in many cases, right? Especially in OpenStack integration, we have seen how hand in hand they go. But if you look at the OpenFlow, right? When you write a flow, you know exactly what to expect, right? Absolutely, yes. But in OVSDB, it's a database, end of the day, right? You write the database, it's really up to the implementation on the vSwitch side. They can do various other things in very different ways. For example, a new implementation of an customized Open vSwitch, right? They can detect elephant flows maybe, right? It's already there, right? The IP flow maybe. So if the implementation can do that, they can write their own schema called the IP flow. I think they already have it.
Yeah, that's true.
And the better implementation can keep updating their schema, right? And we'll keep getting the new stuffs to us rather than in OpenFlow, we have to be standardized, of course. We need to standardize it, go to 1.3 and make sure things work fine. But here we can do more innovation, right? And you can easily get to the community, much more easier. Because end of the day, it's a database. We're not talking to an implementation detail, we're talking about a database end of the day.
I think one thing that might help too with a lot of questions is, in classical OVS, vSwitch, typically you have OVSDB and you have OVS. OVS is the switch side. That actually drives the data plane. There's always talking to OVSDB. There's always and that's where all the management's coming down. So you would configure down to OVSDB, then OVS, the vSwitch, is always getting updates of that configuration. And if there's port changes, it'll also push back to the database. So there's that separation there, the endpoint side and the management and control side that's coming down to that database. They're always in pair. I think that's the key difference.
Right.
It'll show you how you're driving through OVSDB and some data planes down to the vSwitch side. But classical OVS always got those two pieces.
Right. That's an awesome point, Sam. And we actually don't have that in our slide, and we should. If you go to the RFC and look at it, there's basically two daemons that make up, when you do a yum install Open vSwitch. Good. Sorry, joke. Which works really well now, and we're happy about that.
It's not AppKit anymore.
Yeah. And so there's a vSwitch D that is the user space data path, and then there's a little piece of it that is the upstream kernel module, and then you've got OVSDB server, which is what we're talking about. So yeah, thanks for that. It's a great point. And I'm going to jump back to one slide that we skipped over. Oh, here we go. Not the cat. So what's highlighted there, so this is probably the sexy part of OVSDB, and that's the tunnel configuration. We get excited about these kind of things because we're nerds. So if you look at the top, it might be too small to see, but you've got a manager and you've got an OpenFlow controller for that bridge. So again, those are two separate functions. In this case, they're pointing to the same controller. There's just a Boolean underneath it that's true, whether it's connected. And then as you dig down a little bit, you actually get into the tunnel and the overlay components of it. So they've done one really cool thing, obviously lots of cool things Ben and Justin and Jesse and those guys have done. Key equals flow. So in 1.0, since you only have one table, thanks.
I can't highlight it.
I know, I wish we could. Since you only have one table, you don't have the option of saying, because what this is actually saying is, I want to set the tunnel ID in the flow mod. So as opposed to going in with OVSDB and hard coding in this tunnel is dedicated to this GRE key or this VNI key. Those keys are simply tenancy or network IDs or however it is you're partitioning and keeping path isolation for security policy. You're actually setting it in the flow mod. So it's kind of cool. If you had 2 hypervisors and 20 needs for separation, whether it's tenancy or whether it's security, you would have to have 20 different tunnels. So by using OpenFlow with the flow mod and saying, here's a flow and here's what the tunnel ID on it is, it kind of generifies the configuration in OVSDB. There's also a mechanism to set the IPv4 tunnel destination IP, where you could set a remote IP equals flow. So now it's, because tunnels are stateless. They're essentially, they're no different from MPLS. You slap a label on it, and it goes to the other side. Now that is, and that gets into Nasiri extension lane. So OpenFlow does not, OpenFlow 1.3 doesn't specify IPv4 tunnel destination. There are references to NXM code points, and actually the OpenFlow library has those in the controller. So it's up to us in the room and everybody else involved in the project to decide, does that make sense? Do we upstream that? Because again, we're just doing what makes sense, not strategy, not religion.
Yeah, so just to be sure, for those who is too technical, too nerdy here, what you're seeing here is the overlay tunnels, right? All the well-known overlay that we all keep talking about in the overlayers underlay. These are the, sorry.
I'm just jumping ahead.
Yeah.
So you can actually
so the overlay tunnels that we're talking about, it's exactly what we are showing. If you can go back, it's fine. Right, so.
Oh, I got it, buddy. Which one do you want?
The actual thing.
Got it.
Yeah, so you see the VXLAN type, right? That is a overlay type, and the source IP, dash IP are the tunnel endpoints, right? So this is the overlay that we all talk about. I mean, a lot of discussion happening on the same topic, right? This is the edge overlay, and as Brent pointed out, this is purely OVSDB side of things, right? The other coin is the OpenFlow. That's why OVSDB and OpenFlow, they go hand in hand. That's why it's very important for us to understand the feature set of OpenFlow on the OVSDB side to see which goes really well together. So even the OVSDB neutron implementation that we did recently for the hydrogen release, you'll see two different implementations. One with OpenFlow 1.0, where you will not see this kind of overlay. The overlay will be more 2 nodes. You'll have each tunnel per tenant. With 1.3, OpenFlow 1.3, it supports the key equal to flow, the one he's talking about, right? Where we can pass a GRE key on the pipeline, and OpenFlow can take that and rewrite that. That way, we can orchestrate really well between these 2 protocols, where I can write key equal to flow, meaning I can have just only one tunnel, one overlay tunnel between any 2 compute nodes. At the same time, I can achieve all possible scalability across all tenants, right? Say you have 1,000 tenants, even though you have just one tunnel. In 1.0, you may need 1,000 tunnels, right? So OpenVSwitch is a good place where both this world meets, the OVSDB and OpenFlow. That's why we try to call it beyond management, because it enables much, much more than a simple management can do. Yeah.
OVS version 2.0 is OVXN and two virtual router at the same time. I was going to show you VXN. I do support neutron as well. Neutron plugin at the same time, right?
Can you come again? What's the question? I'm sorry.
You have the port created by VXN.
Right, that's a VXLAN port, yeah.
So you also have another example showing the ports created by VXN and another group of ports created by the Q virtual router. L3.
Oh, L3 agent. Yeah. So yes, I mean this is a BR int, right? It's an integration bridge. Right. So it's a regular bridge, isn't it? So multiple ports, yes. But in this example, we don't have it because we haven't supporting it in the. Oh yeah. But just that we haven't implemented it yet.
Yeah. No, the only difference is it's just a port tapping into the namespace.
Yeah.
Yes. Does that answer your question?
Right.
I need not. I need to namespace.
So Linux network namespace is absolutely necessary. Router namespace.
Right.
Yeah.
Right. Yeah. So.
Very quick question. So obviously the whole information is part of the OVSDB. What happens if you manually change the flow? You want to incorporate service change. Is that part of OVSDB or that's not part of it? So for example, let's say you implement service chaining using, just for the heck of it, just OVS events.
Right.
Are those modified flows that you put in, is that stored in OVSDB or not?
No. So flows are all. It's all open flow side of things. If you look at the RFC.
Even if you modify the flow.
Right, even if you modify flow. It's all open flow is a separate thing, OVSDB is a separate thing. This is isolation, of course, but it's a tight kind of correlation where if you look at the open flow rules, maybe you can jump there, right?
If you go out of sync, right?
Yeah, that's the
Yeah, of course, yeah. I mean, it's possible. That's why we have a controller, that's why we have a manager, that's why it's better to have a uniform kind of a vision, right? So the thing is, if you look at the flows here, right, as if you look at the import, the output, and all those details, these are the open flow ports, right? So when in the implementation, the port represents the corresponding OVSDB interfaces, right? So they go hand in hand. But there's nothing is going to stop you by inserting a flow, right, which can do bad things for you or service chaining. It doesn't matter really, right? End of the day, OVSDB is a separate management thing, and this is a separate one. And the OpenDaylight controller orchestrates both of them beautifully, right? They have two channels, and we have application like Neutron, which we know, okay, we need tenant isolation, right? Okay, then we need to create these tunnels, GRE VXLAN tunnels. So we use the OVSDB to create those tunnel ports attached to the BR end, and we go to the OpenFlow 1.3 or 1.0, say, you know what, dude, we have this port already created, right? So for this kind of flow, needs these kind of overlay information. So we use that. So there's nothing one limiting another one. Both can innovate on. In fact, we want that, right? Because even in an overlay scenario, even though we establish a OVSDB based overlay tunnel, there can be tens of thousands of applications which can be run on top of that. We don't want to say, hey, this tunnel belongs to this flow. We don't want to say that, right? Of course, we need this separation so that applications like service chaining can just come over it, and now we are talking about load balancers and firewalls and so on and so forth. We need a separation. We need it. Yeah.
The question is like, why do you have a separate things like OVSDB and OpenFlow? I understand one is management, one is DataPlane. If you take up the hardware VTEP, right, they kind of combine it both. So only the day the controller gives you calls an OVSDB call, like Mac when it wants to program from Mac, all that translates into a DataPlane operation. So why do you want to have it separate?
Well, so I know there's debate going on, I believe, in the ONF on this. I'm not on the listservs or anything, but I mean, I think there is a debate right now on does it need to be separate? I think that's we're pretty agnostic to it. Yes, sir.
There's a really simple example that helps illustrate why it's useful to have them separate. A hardware switch has a pre-programmed physical construct of ports. Virtual switch has no such thing. So how do you even create the switch and create the port with OpenFlow commands? You need something to specify what is this switch. And OVSDB, that's its primary purpose, is to configure the switch. And physical switch doesn't have the same, it's physically limited. You've got 48 ports.
To make it even more simpler,
OpenFlow
right?
doesn't even address
Yeah.
port creation. I mean, CRUD operations on ports and bridges is outside the scope of the spec.
So the point is good, very valid point, right? It's not just about OpenVSwitch, right? OpenFlow is not OpenVSwitch specific. OpenFlow is for anybody to implement. Even that, do you know one hardware which implements it thoroughly? Just OpenFlow, right? If you can name it, I'll be happy to refer that, right? So even if you cannot implement the one OpenFlow 1.0 properly in hardware, why do you want to load with more stuff on that, right? First, let's implement basic ones, right?
Yeah. And if it's the right thing, we should evolve there. I think that's reasonable. Well, we'll see. Yes, sir.
On
you're talking about orchestration here, right? Where hopefully we have that code in place. I had to go back and check, right? It's because the if you look at the OVSDB implementation, we have multiple layers, as I was explaining even yesterday. The first layer is the library layer. Library layer just talks to one device and programs that. That's all it does, right? So it's a transactional. Every programming is transactional, right? So either the transaction succeeds or fails for a given box. Plugin, of course, it again talks to only to that particular it takes schema, right? Now we talk about the OVSDB Neutron, right? That's the application which orchestrates across different nodes, right? This is nothing specific to OVSDB, right? Even OpenFlow has the same problem. Even any protocol for that matter, right? Southbound, if you are orchestrating multiple devices using a given southbound protocol, how do you ensure consistency across, right? That is something a bigger question on the controller side, where what is the mechanism that we have today, which provides consistency across different programming, right? Having said that, I mean, for OpenFlow, we kind of achieved using infinite span. Infinite span is kind of a mechanism where we can create transactions, right, across different flows. And if transaction succeeds, then we do a commit. Transaction fails, we go roll back. We do it. If you look at OpenFlow today, we do it. For OVSDB, we are not doing that, right? It's an implementation gap. We recognize that, and it's a bug. It's still open. Patches welcome. Yeah, thanks. In fact, that's how we roll here, right? I mean, we tried very hard to get this. See, we had this OVSDB code in place for some time, right? But we were using Postman to execute that. It's not too cool, right? That's when we started working on the OVSDB Neutron. Then it's a couple of months, really. We got that working. Of course, there are a lot of holes, really, right? That's why hydrogen release is mostly for you guys to try it out and give us feedback. Like this is a very valid feedback, which we know it's not there already, but good feedback. And in the forum like this, if you bring it up, somebody interested in this computer science stuff, right? This is a computer science problem rather than a OVSDB problem, right?
It's actually not a separate problem. What if you have 10,000 nodes? You have to go serially configure all of them. You have to go very
It is a complicated problem, right? And something called XA resource, I'm not sure if you guys understand. I mean, Chris knows about it. So XA resource is something which we can start thinking about, where it is something where we can provide transactionality to the hardware programming as well. It's not just software transactionality where in software transaction is achieved already, right? You can have commit, commit and revert process, rollback process, which achieves today. Like infinite span, we have it already. When it comes to the hardware programming, that's where things starts breaking up, right? So we have XA resource is one thing which we can start thinking about for OVSDB and OpenFlow and whatever protocol that you're thinking about. But today, we don't have it. But it's a very tough problem. It's a not easy problem to solve. Yeah.
And when you actually look at scale, if you look at I believe the VIF driver in OpenStack, so libvirt actually pulls the OVS. So port is actually created, deleted. Use it in OpenStack using Nova sends to libvirt, and libvirt actually does that. That pulls it every 2 seconds. So literally every 2 seconds, the entire database is getting downloaded and in a monitor. So this is orders of magnitude more efficient looking at this way as far as when it comes to scale. So if you're pulling the whole database every 2 seconds as opposed to just pulling a small change when the data path changes, and the rest is just keep alives. So it's a super valid point. And OpenStack, if you look at that now, I mean, that's to the point where it's going to be a scale problem that probably is, at some level of scale, needs to be offloaded to a database, external.
So typically such problems, if you look at typical systems, how they solve the problem is, they have this background consistency checker that keeps running, right? That keeps checking the consistency across the system. And then if there's something is wrong, they highlight it saying, don't trust that. Or sometimes they go and remove it and say it's failed, right? And there are systems which correct it as well. But yeah, today we don't have that. Yeah.
How much time check? I just want to make sure.
Yeah. Oh my God, we're almost there.
Yeah, we're almost at. So probably the one thing that we're really proud of in the community, that all the guys and girls that worked on this project are proud of, is that our implementation with OpenStack integration is not using vendor extensions. It's not using anything proprietary. There's only two protocols used for it. One is vSwitch, or OVSDB, obviously, and the other one is OpenFlow 1.3. And the main thing that 1.3 gives us is multi-table. So we've got this pipeline that's a real pipeline instead of just a pipeline of one flow table. Flow tables are an ordered list. So the first thing that matches, that's it. Doesn't matter if there's something after it that's even a longer prefix match for anybody that's on the LPM side of networking. So the advantage of this is we've got the ability now, we've got all these different tables, literally start implementing things. I mean, you mentioned service chaining. We've almost got a service chain within the OpenFlow pipeline there. And so we're leveraging, the go-to in OpenFlow. And so, right now it's pretty simple. It's either ingress. We've got a table 0 that's a classifier. Comes in on that. It's either going to be an ingress or an egress operation, mainly differentiated by a tunnel ID. So if you've got tunnel ID on there, you're coming from another hypervisor. So if you had 100 hypervisors in your cloud, there would be 100 ports, one going to each one of those. If you that's kind of the advantage of setting an IPv4 tunnel destination. If you had 100 hypervisors and you were able to set that in a flow mod, you would just have one port. So that's possibly attractive. And so here's just kind of our breakdown of the ports. And it can be any, right now we're just mainly tunnel ID and DMAC and setting it to a tunnel destination. Actually, that tunnel destination there is an extension.
Yeah.
Whoops. Really quickly, we'll run through OpenStack. So OpenStack today looks like OpenStack used to prior to ML2. Lots of agents. If you have different types, you've got an agent for that type. Problem with that is agents don't scale. They're not easy to manage. If you need to innovate upstream in the core of the application or in the core of OpenStack, well, now you're only as good as your lowest common denominator. So that starts to get consolidated. The ML2 plugin or mechanism driver, that's what interacts with OpenDaylight. Let me skip ahead. And so this is kind of what the final is. We definitely want to say this isn't like a product demo for one. This is just what the community collectively has put together as a good first step, because we can do this in software. There's no constraints. I mean, you're virtually unlimited in resources when you're comparing, 64, 128 cores, or 64 cores and 128 gig of memory as opposed to TCAM and a T2 or something like that. Even with CAM binary lookups and ordering and that, it's still pretty significant. But we're certainly, like, things that VTN are doing, it's really cool because they're tackling tough problems, and that's how do we get visibility in the underlay. So as hardware evolves, I think that becomes easier.
So I just want to show it, this one. A lot of folks ask, is there a design document that you guys do for writing the code, right? This is it, right? So we don't have design documents, right? Thanks to Brent, and we kind of go out there and draw all these nice pictures, right? And the geeks folks, we just keep looking at this hours together and start coding out of this, right? So anybody asking for design documents, this is what you end up getting, right? So
if you want to add a port, there you go.
there, yeah.
Simple.
Where do you start?
Thank you.
That's the one.
All right, well, yeah. Well, and so on top of that, like, where really would you start? So we do weekly Hangouts. Unfortunately, Hangout is limited to like 10, but we live on IRC. It's irc.freenode.net, OpenDaylight-OVSDB. Thanks to everybody in the room that has contributed. The list is too long to even start with, but we really appreciate it. We're working through roadmaps over the next couple weeks, so if there's something that would help your organization, and even better if you have some code to pick off something on there and see upstream. Any last questions?
Yeah. So we are done, guys.
Thanks, guys. Hey everybody, my name is Brent Salisbury.
I'm Madhu Venugopal.
We're both with Red Hat. Today we're talking about vSwitch, vSwitch database protocol. We want this to be, I mean, we've got slides to kind of reference, but we'd love to have some interaction because it's just boring hearing us talk. And so please just interrupt. Call foul. We're going to ask you guys questions because, you know, we're developing this stuff with community. So some of you guys in the audience, whether you work for a company or don't work with a company, we want to work with you because, you know, we work for Red Hat and we do what's best for the community. And as somebody that just joined 2 weeks ago, I can honestly say that is the only direction. So when we say that and we sit in meetings, it's what's best for the community. So we just got out of lunch. We like cats. Figure out where you sit in here, and you know, we left it generic. So interpret it how you will.
Yeah.
So vSwitch database, it is reference RFC now. For the most part, you can think of it as a management protocol. It does have functionality that's beyond that, and it's kind of morphing into more of it. You know, we've had SNMP, and you know, we can kind of go down a list of failed. Well, you know, people look at SNMP and say it's a failed management protocol, but we've had SNMP for at least 15 years, so I'd probably call that a pretty good success, just for something to be as widely deployed as it is. But you know, it's getting a little long in the tooth. So vSwitch came out of Nicira. It's now published, and it's nothing really more than JSON RPC with a schema attached to it on the software side. There's also a hardware schema, so you know, it's nothing more than here's what this model looks like. And you can go down the list. We don't want to really read it to you because it would be boring, but CRUD operations. Probably some of the highlights with the controller though are going to be it can be set as a listener, so it's just going to have an open port on either a controller or a manager, or it can be sitting on the switch. So there's going to be a port sitting there listening on 6640. Some of you probably remember it as 6634, things like that, but it's actually a registered IANA port now. And it can either be an initiator or a listener. So the main thing, there's probably one provisioning piece to this, and we were talking to some guys from PayPal eBay yesterday on how to maybe figure out how to make this self-configurable, or some discovery mechanism to it. But you'd have a vSwitch that you would either need to say, I want you attached to this controller and now start programming the data path, or you would have the controller attached to the vSwitch and begin the initiation. It's got these little 5-second hellos that keep persistence. The second anything changes on, so if a port goes up, there's going to be a notification message that comes in. It's all JSON. It's going to notify of a port that's there, and vice versa. If you modify a port, so any change at all in that database, there's going to be a message thrown up to the manager. So it's pretty cool. You get real-time understanding and state of the configuration in the network. It also does include things like MAC addresses. So if you have MAC addresses on being learned on, let's say, a learning switch of some type, that's going to be there. Or you just program in as a reference.
These switches, right? Then of course we started looking at the reference platforms and looking at the OpenVSwitch, OpenVSwitch agent, right? Then we saw a lot of CLIs being executed on the compute nodes, right? Then we figured out, okay, why would we need a CLI? Then we started digging deeper. Then we started realizing about OVSDB, right? Till then, we didn't even know about OVSDB, right? It's like a few months back, really. So once we started OVSDB, of course, we both started looking at there's no RSC at the time, it's only pure draft. So hacking on things. It's again a simple bidirectional JSON RPC. We hack things. Nothing really great about it, right? It's simple stuff for us. But once you start writing applications on top, right? then you start realizing it's not just a protocol, really, right? It's really an enabler. It enables much beyond a simple protocol can do, right? So once you start writing simple library, so we wrote a library called OVSDB library, hacked it up, made it work. It's all great. Then we wrote the layers on top, right? The REST APIs for that. It's pretty cool because once you have REST APIs, any application can talk. You don't have to be a SNMP kind of a client. So then we started writing Postman scripts, right? And then calling scripts to configure the OVSDB, right? That worked very well. Then started using the OpenStack interface, right? So let's look at OVSDB as a simple API mechanism, right? You call the API. In fact, the reason it's called JSON RPC is really a remote procedure call. There's nothing beyond that, right? How we implement the actual protocol inside, whether it is a TCP session or how do you maintain session, it's totally a library specific one. Right? From an application standpoint, think about it as a remote procedure call, and there is a database running on the OpenVSwitch. Magically, if you update the database, something happens on the data path, right? Just imagine that way, right? That is what OVSDB is all about, right? It's nothing more than a RPC call with a database on the other end. You change the database, things magically start happening on the OpenVSwitch side. The beauty behind the OVSDB, as we all know today, is that it is not a hard-coded database table, right? It is schema-driven, and the schema is exposed based on the RFC. If you look at the RFC 7047, it doesn't dictate any schema, right? OVSDB, of course, one of the primary uses on the OpenVSwitch. It is essentially two parts. It's not just one part, one phase. It's two phases actually. First phase is the RFC itself. It talks about what are the different methods you can call, like create, modify, listening to the updates, monitoring, so on and so forth. That is the actual protocol piece where now you explicitly say that these are the different mechanisms that this particular protocol must support. Additional to that is the schema, right? The schema is where the real things starts getting interesting, really interesting. OpenVSwitch has its own schema. We are hearing new protocol vendors, new hardware vendors. They use the same OVSDB RFC, but they have their own different schema, completely different schema. It's called like hardware beat-up schema, and so on and so forth. A lot of guys are coming up now. So what happens here is, we write a simple library like the one that we have in the OpenDaylight. It's quickly becoming the reference implementation in kind of Java world, where we write the library and the plugins, we give it to the community right out there, and we started seeing like already 3 or 4 vendors and research community started taking it up, writing their own schema, right, and exposing themselves. So now, as we are discussing here, right, the title is aptly suggested by Brent here, where it is not just a management protocol really. It's really an enabler for various other aspects of things, right, like OpenStack.
Yes, sir.
I'm new to OVS, so if somebody runs OVS control on the Linux box, does it go and modify the local database and then that will send the event, or does it directly? You see what my question is? So
Yeah.
if somebody runs a command line interface on the operating system itself, does it talk to database and then that sends out the event?
Yeah, so the OVSDB, as I was explaining, right, is a bidirectional. Oh, sorry. So his question is, OVSDB is a control management channel between the controller and the server and the client, right? Server is the host, the node that is running the OVSDB server, while the client is the controller in this case, right? If somebody touches the CLI on the compute node or the node, does it get reflected back on the OVSDB and comes to the channel, right? The answer is yes, because the OVSDB is a bidirectional JSON RPC. So there can be multiple clients which can be acting on the same DB. The client can be CLI is a client, right? And the controller is another client. So any update happening on the database gets reflected back to the monitoring process, right?
So when you run something on the CLI, it first goes to change the state of the DB,
right?
And then that goes change the kernel and everything. That's how it works.
Yeah.
Not some IAPTOs or something directly to
No. So before we go deeper into this lot of words here, right? Anyone here is really new to OVSDB or have any questions about? Oh, there you go, right? Questions about why do we even need OVSDB or anything like that? Even more basics than that, right? 2 or 3, right? I think it goes a bit more.
Oh, yeah.
Yeah.
Cool.
Right. So before going into this one, right? When we started working on this project like a few months back, we know of OpenFlow. All of us knew about OpenFlow. We are like going deeper inside. Then we started looking at OpenStack, looking at the integration piece. We didn't find any good way to manage